we're going to be getting into chapter 4, which should be a little bit of a review, or should look familiar to what we've done before. And so we're going to talk about trigonometry. And so the definition of trigonometry is triangle measurement. Where that comes from is the root word trigon. Okay, trigon means triangle. And metry means measurement. Okay, because remember we learned about geometry. Geometry was measurement of the earth measurement. And so trigonometry is triangle measurement. And so these should be review, these trig functions. 3 of them should be review, 3 of them should be new. Okay, the first 3, sine, cosine, and tangent, those should all look familiar. Notice here, whenever we refer to an angle, we use the symbol theta. So that might be something new. All you do when you write it, I just write it, that's one way. I write it that way as well. Okay, but that's just a Greek symbol generally used to symbolize an angle, and it's theta. Okay, so sine of theta equals opposite over hypotenuse. Okay, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Now we had a nifty little acronym.
Subcot.
There you go. Okay, that was used to remind us of the order. Okay, now that should be ringing a bell as well. Okay, and so we now have the 3 other trig functions. So there are actually 6 functions, but the second 3 relate to the first 3. So that's why it's so important to get the first 3 down. Cosecant is abbreviated CSC. It's hypotenuse over opposite. This is another way you will see it written. It's 1 over sine. So basically cosecant is the flip of sine. It's sine's buddy. Okay? These 2 relate. Secant relates with cosine. Cosine's buddy. Cotangent relates with tangent. Now, a little bit about that, because some people kind of get screwed up and they're like, how do you remember which one goes with which? Well, the cotangent one should be obvious. Okay, we should be able to take that one out of the mix. And then the question is, how do they pair up? This is how you can remember. It never goes SS. Sine can't go with secant. It always has to be opposite. Okay? Sine has to go with cosecant. Cosine has to go with secant. So they're opposite letters. So that could be one way. All right? So now we're going to actually look at a problem. It says find the exact values of the 6 trig functions. So there is our triangle. I have sine, cosine, tangent, cosecant, secant, cotangent. Now the only way these work is in a right triangle. The other thing, I'm going to require you to answer these in fraction form. No decimals at all. Even when we get to the square roots, no decimals. That is what the exact values mean. No decimals. Exact values mean fractions. So on your homework, on your quizzes, on your tests, when it says find the exact values, that should automatically trigger no decimals. Okay, you're going to find out a lot, especially when we get into this trig stuff, that we don't use decimals a lot. We use a lot of fractions because they're more precise. Okay, when you have decimals, you have to round. So sometimes you can get off a little bit. So, very first thing, what I'm going to do, and you might remember this from before, here's my angle. So what I'm going to do is I'm going to label my sides. Remember, I have 3 labels: opposite, adjacent, hypotenuse. Which one is the hypotenuse? The longest one, which is always, it's always the one opposite the right angle. It is always the one opposite the right angle. That's why we start with that one. Now we have 2 other remaining sides. We have opposite and adjacent. Once you've labeled the hypotenuse, the other 2 should fall into place. Because between these 2, which one is actually opposite the angle? Which one doesn't touch the angle? 8. 8 is my opposite, which therefore leaves 15 to be the adjacent. Another way to think about that, the adjacent always touches the angle. Okay, the adjacent and hypotenuse always touch the angle. So now all I'm going to do, sine I know is opposite over hypotenuse. My opposite side is, my hypotenuse is, so 8 over 17 is your answer. Okay. You can't reduce it, so you leave it 8 over 17. What about cosine? 15 over 17. Little tidbit, your denominator should match on sine and cosine. Okay, what about tangent? 8 over 15, opposite over adjacent. Okay, so now if you've done those first three right and you're relatively confident, the next ones are just the reverse. Okay, so cosecant is going to be the flip of sine, so 17/8. What will secant be? 17 over 15. What will cotangent be? 15 over 8. So the only one you have to find are the first three. The other three you just flip them. Questions? Think you can handle that? All right, let's look at this one. If cosine of theta equals 2/5, find the exact values of the 5 remaining trig functions. Now, believe it or not, this problem is very similar to the one we just got done looking at. It's just written a different way. So what I like to do, I always start this way. I make my answer area, my answer key. And so every time I have one of these problems, I go through and I write down all 6. And I know some of you are like, well, we don't have to do all 6. Well, I know, but it just makes things a whole lot easier if you just write all 6. Okay, we can already fill one of them in. Cosine is 2/5, which means that secant, you were right on track, 5 over 2. So there you go, you've already got one of the 5 done. Okay, you should always be able to get one of the 5 on these problems, always. So now we have to draw ourselves a triangle because I don't really have anything to refer to right now. So I'm just going to draw a random right triangle. Doesn't matter how it looks. I'm going to pick an angle to be theta. Once again, it could look like the one we just did on the last page. You could draw another right triangle. And I'm going to label some sides. I know that cosine is what side over what side? Adjacent over hypotenuse. Okay, so one of these I know right away. I know that this one's 5 because that's the side opposite the right angle. Which of the remaining ones, the vertical or the horizontal, is the 2? The horizontal because that's adjacent. So now we got to find the missing side. So ideas. A squared plus b squared equals c squared, that Pythagorean theorem that we learned. You're going to have to use that a ton when we get into the trig stuff. Okay, so I have 2 squared plus, I'm just going to call this, I don't know, we could call it a squared. You could call it x squared 2 equals 5 squared. So I know 2 squared is 4. What is 5 squared? 25. Okay. What's a squared equal? 21. So now, how do you solve that for a? Square root. Now what's the one thing I told you could, yep, plus or minus, and this one will have to be positive only. We can't have a negative side. So we don't have to worry about the plus or minus here. But if you remember what I told you, we couldn't have decimals. Okay? So I'm going to leave this as 21. By the way, could I break 21 down any? Okay. If you could, you're going to have to do that. Like last year we learned how to break down square roots. See, all of this is coming into play. So I'm just going to leave that as root 21. So now let's start filling in what we know. What is the sine of theta? Root 21 over 5. Okay? What is the tangent of theta? Root 21 over 2. Cosecant. 5 over root 21, but I will not allow you to have square roots in the denominator. We need to simplify those. So remember how we simplified them last year. We multiplied by root 21 over root 21. So really, I end up getting as my fraction 5 root 21 over 21. Remember, those two squares on the bottom cancel each other out, and that just leaves you with 21. With that in mind, cotangent is going to be what? 2 over root 21. And I would encourage you to make sure you write that down, because if you make a mistake simplifying, I'm not going to take off as much if you have the first one. Okay, so what am I going to do now? Root 21 on both the top and the bottom. So really I get 2 root 21 over 21. Questions? That's all you do right now. So now this is what I want you to do. We're going to look at two special right triangles, and you looked at these a ton in geometry. Remember the 30, 60, 90s? What?
No.
You got geometry. I think you guys looked at that. Okay, the 30, 60, 90s, if you remember the relationship between the sides. Okay? The relationships between the sides is you have your right angle. The side opposite 30, remember, is always half the hypotenuse. Okay, side opposite 30 is always half the hypotenuse. The hypotenuse is always twice the shortest side. And the side opposite 60 is always root 3 times the shortest side. Now you have to file those to memory.
So like that left side wasn't originally
Yeah, we'll look at an example. Okay? You just need to make sure you file that away. And I know we looked at a ton of these because I remember we made flashcards. Okay? You made flashcards with all of these. So let's start with a simple one. Okay? Let's find the two remaining sides. Okay? So hypotenuse is 8. So if the hypotenuse is 8,
Sure.
the vertical side is what? 4. It's always half the hypotenuse, right? What's the side next, the horizontal side, going to be? 4 root 3. Okay. Let's try another one. Oh, just a sec, I gotta put angles in, sorry. Which one is? That one, the diagonal? Okay. 13 root 3. Good. Okay.
No.
This is always the one you hate to see. I'm going to warn you right now. You hate to see this one.
3 divided by.
Okay, so let's think. Okay, obviously I have to find either the hypotenuse or the vertical side, and then it's going to be pretty easy. Whenever you're given the side opposite 60, this is the side you're going to find. So what I need to do is look back at my relationships here. When I knew the vertical side, what would I do to get the horizontal side? You would take it times root 3. Now, if I want to undo that and go backwards, I'm going to divide it by root 3. Right? So it'd really be 3 divided by root 3. But you know, can't have a root in the denominator.
So
Okay. Times root 3 over root 3, which is 3 root 3 over 3, which is just root 3. Good. So then now, what's your hypotenuse going to be? What's your hypotenuse going to be? What's your hypotenuse going to be? I will tell you right now, it's not root 6. Say it louder. 2 root 3. Okay? Because it's twice the shortest side. It doesn't say root 2 times the shortest side. It says twice the shortest side. So if the shortest side is root 3, it's 2 root 3. If the shortest side is root 10, it's 2 root 10. It's double whatever it is. Okay? All right, 30, 60, 90s. You've got to file them away. Okay? And this is why you've got to file them away. Because we're going to be getting into this long chart that you're going to have to fill in with all these exact values. If you can get this down, it's going to be a lot easier for you. 45, 45, 90. Isn't as hard. Okay, it's a little more straightforward. The nice thing about a 45, 45, 90 is that 2 of the sides are the same. Okay, it's actually a nice isosceles triangle. So your hypotenuse is always root 2 times the side. And it doesn't matter which one because they're the same. Okay, let's fill in the remaining sides of the triangle on the first one. The bottom one's 5? 5 root 2, good.
So the bottom one is just like the last example.
Right. The bottom one, okay, if you notice I didn't put 45, 45, but I put that the 2 sides are the same. So if the 2 sides are the same in a right triangle, it is a 45, 45, 90. Okay, and so, how do you go backwards? You divide by root 2. Good. So I'm going to divide it by root 2. But, can't have that. So, root 2 over root 2. So I get 10 root 2 over, so your side is actually 5 root 2. I'm going to show you a trick. If this is 12, my answer is going to be 6 root 2. And? Okay, that's one of the things, if you want, this is an option in this, you can understand that all you do, take half the hypotenuse, multiply by root 2. So to go backwards, you take half the hypotenuse multiplied by root 2. So that's one of those things, if that works great for you, fine. If it doesn't, divide by root 2. Alrighty, here we go. We're going to start using your calculators. Real quick, let me just double check how many more we got. Alright, so it says, oh shoot, there we go. Okay, so it says find the value of x right into 2 decimal places. So we're just solving right triangles. Okay. So I'm going to start with my angle. What side is 18? Hypotenuse. What side is x? Adjacent. What ties in? Adjacent hypotenuse.
Cosine.
Cosine. So I'm going to write my equation. Cosine of 42 equals x over 18. Yep, because it's an angle. So now, this is what you're going to do. You're going to use your graphing calculator. Now, what I need you to do on your graphing calculator right now is we need to make sure that we're in degree mode, because chances are you're probably in radian mode on there. So I need you to go ahead and go to mode. It is located by the blue button on the top. You should notice that the third one down says radian or degree. You need to make sure you're in degree mode. Okay. The third one down, move that to degree mode. Okay. Now you can go ahead and exit out or quit. And I want you to go ahead and we need to use that to solve this. So this is how you're going to solve the equation. How do you undo x divided by 18? You times it by 18. So on your calculator, you're going to type in 18 cosine of 42. 18 cosine of 42. Okay. What'd you get to 2 decimal places?
13.38.
You got the cosine? 18 cosine 42. You could put a time sign, you don't need to. $13.38. Did anybody not get that? Because if not, we need to make sure that everybody's got that. So 13.38. All right, so we're going to look at another one. Okay, so as you're writing that down, I want you to write down the equation we would use to solve that. What do we have for your equation? What?
I didn't know which ones are
Which one's going to be your hypotenuse? X. Okay. 15 is what side? Opposite. So what ties into it?
Sorry.
Sine. So I know that the sine of 50. Now the question is, how do you solve that with x in the denominator? Okay. There is a way. You have to multiply both sides with x and divide. Or if you can get the shortcut down, it'll save you a lot. You switch those two. You just switch them. X equals 15 divided by sine of 53. It's basic. Well, yeah, you need to calculate that. Okay, it's basically the same. We're just cutting out 2 steps. Now, on your calculator, I'm going to teach you something that'll come in very handy in the future. You need to make sure whenever you have a fraction, you've got to use parentheses. Okay, now it's probably not going to make a difference on these problems, but it will when we start getting more in depth. So you need to make sure you get in that habit early on. Divided by? Yes, 53. What'd you get?
18.78.
18.78. Does that make sense that that side should be bigger than the 15? Yes, because it's the hypotenuse and it is the biggest.
How'd you know that? 15
Because it's sine of 53, this angle, equals your opposite side divided by your hypotenuse. Okay, let's look at another one, I think, after we practice a few more. Now you're going to be getting into some story problems. Okay, these are no different than the problem we got done doing. They're actually just the same. A competitor in a hiking competition must climb up the inclined course as shown to reach the finish line. Determine the distance in feet that the competitor must hike to reach the finish line. Okay. Okay, so 1 mile means that this is 5,280. So that's your adjacent side, right? But where is he actually hiking? He's hiking to the flag. So where's he actually going to be is right here. So this is what I'm trying to find. Okay. So let's go ahead, because there is another way you could find what x is and then just use the Pythagorean theorem, or you can just find y to start with. So let's figure out, you said this was the adjacent, what's y? Hypotenuse. What ties in adjacent and hypotenuse? A and H, cosine. So our equation, cosine of 48 equals 5,280 over y. Switch them. Yep. 5,280 is your adjacent side, right?
Well, yeah,
Divided by y, which is your side
I
right
just
here.
don't get how you know the adjacent is.
Because that's what cosine was defined as being. Cosine was adjacent over hypotenuse. That's your SOHCAHTOA. Okay, does that make sense now?
Yeah.
Okay, so y equals 5,280 divided by cosine of 48. Remember these parentheses? How long did he have to hike? 7,000, say it louder please, 7,000.84 feet. There you go. Well, about a mile and what? Mile and a half? Real close to about a mile and a half. Okay, so this is going to be the same thing, find the measure of theta. We're going to go ahead and jump through these two so that tomorrow we can probably do some other stuff, some group work in that. So it says find the measure of theta. Now this is different because now instead of finding a side, you're finding an angle. But I'm going to show you a little trick. While you're writing that down, you can go ahead and label your sides. What side's 26? What side's 26? What side's 11?
Adjacent.
Adjacent. So now I need to think. O and A. Think back. SOHCAHTOA, what is it? TOA. So tangent. So now, do I know the angle? No, so I'm going to write this as tangent of theta equals 26 over 11. Now, you're probably wondering, how do you find that angle? Does anybody remember? Yep, you use what's known as the inverse tangent. Now, how you're going to notice this is on your calculator, you have those three buttons, sine, cosine, and tangent. Right above each of those three, you should notice there's a sine -1, a cosine -1, and a tangent -1. Those are the inverses. They undo each of those. So on your calculator, you're going to do that inverse tangent. It'll give you a parentheses, and you're just going to type in 26 divided by 11. What do you get theta to be? What? 67.07. Did somebody else get that? Okay, there you go. So that's it. You're just using the inverse feature on your calculator. Okay? Questions? Think you can handle this one? Same thing? Okay. All right, here you go. This is going to look like a lot, but tomorrow we're probably going to do some group work. Okay, it actually is like 25 problems, but you're on page 227. You're going to be doing a lot of the same things on these. 2 through 42, the evens. Yes, you're going to have some word problems in there. And then I need you to do 48 through 54, the evens. Okay, now on 48 through 54, what they want you to do is you need to find all the remaining sides and all the remaining angles. So on 48 through 54, there are 3 answers on every one. Okay, so let's go ahead and look at 48 real quick. On 48, what you need to find is you need to find angle x. Okay, so we're on page 228. So on 48, you need to find angle x. You need to find side y, and you need to find side z. On 50, what do you need to find? Angle D, angle E, and what else? Side D. Okay, on 52, what do you need to find? Angle W, angle Y, side Y. And on 54, what do you need to find? Angle R, side T, and angle S. So the nice thing is once you find one of those angles, subtract them from 180 and you'll find the other angle. Okay? The other thing is you can use Pythagorean theorem too to find the remaining side. All right? So, there you go.